Hey everybody, welcome back. This is CSE 1322, and today we're going to talk about module number 2, part 2, which is we're going to start talking about classes and about objects. So let's get started. The first thing we're going to talk about is the fact that Java, like C Sharp that we're going to talk about at the end of the semester, is an object-oriented programming language. Python is also object-oriented, and it's a very common methodology that's used today for programming languages. So object-oriented programming languages are all based on objects, hence the name. And classes are the definition that is used to create objects. An object is an instance of a class. So let's take a look at what each of those words really mean. So first off, let's talk about classes. So a class is simply the definition of what a object would be made of, what its abilities are, what its attributes are. It's just the definition of what all of them are. So let's take an example. I'm a person. So let's imagine there's a class person. And that class would have things that all people have in common. So like every person probably has a name, they probably have an age, they probably have a height, they have a weight. Those are all attributes of a person. And then we have the abilities of a person. So people can sometimes talk, they can sometimes walk, they can sometimes eat, and so on and so forth. So we have abilities and we have attributes. The attributes were the sizes and the weights and all of those kinds of things, and the abilities are the things that I'm able to do. And so a class is just a definition of what all people would have. It's a concept in the real world. But the other thing in Java and in C Sharp and in all object-oriented programming languages, it creates a new type. Once you have a class for people, you can start making variables of that type. And that allows us to have a model that's running in the software of things that exist in the real world. The whole reason for object-oriented programming is because we want to be able to mimic the real world in software. If you think about a game that you've played, each of the characters in the game is probably a person, or it's a creature of some form, or whatever the game's theory is about. And so there's a class that defines character. And that character has things like its color and its size and its abilities of what it can do inside of the game. And so once you have defined all of those capabilities for a class, then you can later go on and start making individual characters who are of a specific capability, or they're of a specific type. Maybe they're birds, or they're dinosaurs, or they're aliens, or whatever it is that you're using inside of there. So a class is a template. It lists all of the things that a person or a object of that type is going to have. It's going to have attributes, which are just variables. That's what you knew them as in previous languages. So variables are just called attributes. But again, that's going to be like height and weight and name and stuff like that. And then they have functions, which we're going to call methods or behaviors or member functions. And those are the abilities of the character in the game if you're dealing with characters. So this is the smallest that you can do to make a class in Java. So we start off with the word class. We start off with a variable or a name for the class, which in this case is dog, and then you have an open and close curly brace. This will actually compile. So I can go over to my IntelliJ, and the first rule to deal with in classes is that anytime you're making a class, you're going to go into IntelliJ and you're going to ask it for a new Java class inside of your project. It's going to ask you what you want, and I'm going to call it dog, and it's a class, and you see that it automatically put in public class dog. Now again, it has this public keyword that we haven't really talked about. That's going to be there always. Don't worry about it. We're going to get to it later on. But as you can see, I now have a class dog. And if I take that and I attempt to go back to my main method, my main class, and I run my main class, it will actually go ahead and compile both the main class and the dog class, and then it will check to see that everything is good. Now, the main class had this boilerplate code that it had been added automatically by IntelliJ, and so I'm ignoring that. That printed out the 1, 2, 3, 4 thing down here. I'm just going to delete all that and sorry, I use shortcuts in order to make typing faster, and so sometimes you'll see me type gibberish. It's just me typing gibberish. So at this point, if I run it again, what you're going to see is that there's no output because the main method in the main class or the driver class has nothing in it, and the dog class has nothing in it either. You can get between the two classes by clicking up here or double clicking over here. Either will get you there. Okay, so now that I have a dog class, what have I actually done? Well, I've created a new data type. So in Java, in addition to ints and cars and all the primitive types and all the complex ones we've talked about, there's now another data type called dog. So just to talk about this again, we could certainly say int x, and that allows me to make a variable x, which is of type int. But with the definition that we have before, we can now make a dog and a variable y. So dog is now an acceptable type, and I can't do this for any random thing. So like if I say animal z, it's like, no, I have no idea what you're talking about. That's because there's no definition for animal yet. As soon as I create a definition for animal, this will work fine. And again, I would do that with file, new, Java class, and then saying animal, if I can type. And now, back over in main, animal will no longer be highlighted as an error because now there is a class animal, and again, it's just simply public class with curly braces. So that's kind of cool, kind of, but why are we doing this? Well, we've just created a new type that allows us to make variables of that type. We still don't have any dogs in this example or any animals. We just have the idea of what a dog would be. So let's move on to the next topic. So an object. An object is different from a class because it's a specific instance of one of that class. And so, for example, in my example, I have created a class called dog. I don't have any dogs yet. I don't have any particular dogs that I'm using, but I'm now able to create dogs. And so I can have 3 dogs, and they're each going to be of type dog. So that's what an object is. I create an instance of the class to make an object. So it's an entity in the real world. And when you think about objects, they should match to the real world. Like, you are familiar with the idea that you've met somebody who has a dog. And so you meet them and you pet them and they're fluffy and they're a dog. They have 4 paws and life is great. That particular dog is an object to the software because it's one instance of the class dog. If a person has 2 dogs, then they have 2 instances of it. There's still only one definition for the class dog because the definition of what a dog is the same no matter how many dogs you may have. Each dog will have its own separate attributes. Some might be taller, some might be shorter, some might have 3 paws, some might have 4 paws, some might have different fur colors, etc., etc. And so all of those are stored in the object that is each of the dogs. Each dog has its own unique identity, its own unique state, and its own unique behaviors. And so that's the difference between a class and an object. So let's make a dog. We're going to give dogs a couple of attributes. And of course, the first thing you think about when you think about a dog is whether it's rabid or not. Who wrote these slides? Anyway, so dogs have characteristics, and in this case, we're going to talk about whether they're rabid, their weight, and their name. We're also going to give the dogs some behaviors. They're going to be able to growl and they're going to be able to eat. And certainly we could add other behaviors before. So that's what we're going to do in our class dog, is we're going to set up these attributes, we're going to set up these behaviors, and then that's going to be our definition. So generally in a class, you're going to put the attributes at the top and you're going to put the behaviors down below. So let's start off with the attributes. So we're just declaring variables here, just like we did anywhere else. We say Boolean rabid, which we're going to start off as false because dogs are not born rabid, I think. And then we have float weight, which is equal to 0 because the dog starts off weighing nothing. And then string name because, well, they have no name. Again, this is just PowerPoint being weird. These are just double quotes. You don't actually use these weird up and down double quotes. And then underneath it, you have any behaviors that you have. So let's go out to our class dog and let's add these things in. So our class dog, as we said, has a Boolean, which is rabid. It also, there's a semicolon missing at the end there. It also has a, what was it, an age and a height? Is that the crazy things we came up with here? Weight and name. I was close. All right, so we have float weight, which was equal to 0.0, and we have string name, which was equal to double quote, double quote. Okay, life is good. Why is it not happy with this? Oh, because they're supposed to be doubles. Double weight 0.0. Okay, well, doesn't matter. Because I put 0.0, it's assuming that it's a double. That's why I had to change it. Okay, so the next thing to talk about is a constructor. You've seen this much in in Python. You've written classes in Python, and it kind of worked the same way. You said class, there was no public. You said class, and then you said the variable name. And then if you wanted some attributes, you declared them, and then inside of your constructor is where you actually set them up. And the same thing happens here in Java, but the constructor is somewhat optional in Java, and I'll explain that in detail as we go. But effectively, the constructor is a very special method that only executes at the time that a dog is first created. When they're first initialized, when they're created into the world, born, if you will, when they're born into the world, we run the constructor. And the job of the constructor, as its name suggests, is to construct the dog. It's to set everything to reasonable values. So typically what a constructor does is it initializes all of the attributes to something that's sane. Because otherwise you could end up with all kinds of weird things, like a dog whose name is a bunch of random characters, or a dog whose name is blank, which is kind of weird. Although, to be fair, when dogs are born, they don't really have names. That kind of comes later. But anyway, for the purposes of this conversation, we're pretending like dogs are named the moment that they are born into the world, because that makes sense. Okay, so constructors are used to set all of our attributes. So how do we make a constructor? Well, over here in Java, what I'm going to do is I'm going to make a method, which I'm going to call dog, and dog is going to take in no parameters. And inside of this method, I'm going to set all of my attributes. So rabbit is equal to false. I'm going to say the weight is equal to 0.0. And I'm going to say that the name is equal to unnamed dog. Come here, unnamed dog. Come here, unnamed dog. Who's a good dog? Unnamed dog is a good dog. Okay. So the constructor doesn't have a return type, which is weird. This is the only instance in Java where there isn't a type listed inside of here where that flashing cursor is. Generally, when you make a method, I told you, you always have to have a return type. And that was true. Constructors are the one exception. And it kind of makes sense. When you make the dog in the beginning, what are you returning at that moment? I'll let you ponder that for a moment, but you're really not returning anything. So there's no return type declared on dogs. You literally cannot put a return type. If you put the word void in here or anything else, this is no longer a constructor and it's not happy with you. The second rule of constructors is that you must name the method exactly the same as the name of the class. And when I say exactly the same, I do mean exactly the same. Same capitalization, same exact name. So don't call it lowercase dog. That's not a constructor. It has to match. When you're naming classes, you generally capitalize the first letter of the name. It's just to differentiate them, to make them seem like they are classes. You put the capital letter up there. And so when you make the constructor, the name of the method also will start generally with a capital letter. It has to match the class name. Okay, so that's how we created a constructor. So now the question is, what are you doing with these constructors? Well, generally the main thing that you're doing with them is you're deciding what values you want to set all of the attributes to. In this case, we have three attributes. We have rabbit, because that's the first thing you think of with a dog. We have weight, and we have name. And so the three of those are getting set in my constructor to some value that is reasonable. Thus, when I create my first dog, they will not be rabbit, they will have a weight of 0, and they will have a name of unnamed dog, which is how it's supposed to be. So when we create the constructor, you have to make a decision. Do you think that you would ever want to change this when a dog is created, or are all dogs going to be created the same way? So for rabbit, the answer is that all dogs are born non-rabbit, because I said so. So in that case, we're just setting that to false. We're not allowing the user to tell us when they create the dog whether the dog is rabbit or not. We're just assuming all dogs are non-rabbit. And then, when we talk about the weights, are all dogs actually born at the same weight? No, they're not. If you take something like a Dachshund, which is a really small little weenie dog, and you take something like a Great Dane, pretty sure they're going to start off life as very different weights. So when you create the dog, you're probably going to have to specify how big the dog is from a weight. So setting it always to 0.0 is probably not the right answer here. You're probably going to want to be able to take in a parameter that allows you to change the weight. And likewise for the name, they're not all born with the same name. And again, in this example, we're going to assume that they're named the moment that they're born, which I realize is a bit iffy, but we're just going with it for the reason of the example. Okay, so I'm going to make another constructor. I've already made one, and what I'm going to do is I'm just going to copy this constructor so that I have two of them. But in the second constructor, I'm going to take in a double, which I'm going to call W, and I'm going to take in a string, which I'm going to call N. So I'm taking in two parameters. Now, I'm going to set the weight equal to W, and I'm going to set the name equal to N. Instead of putting in hard-coded values, I'm allowing the user to tell me the weight and the name of the animal at the time that it's created, the weight and the name of the dog specifically. And so I'm still leaving rabbit equals false, because I always want to set that to a known value of false. But the weight and the name, I'm allowing the user to tell me what it is, and you'll see how to use this. So let me ask you a question. What is this that I've highlighted an example of? I have two methods with the same name, but they have different parameters. Anyone? Anyone? That's right, they are overloaded methods. In this case, it's called an overloaded constructor. Just like with any other method, I'm allowed to have two versions of the same method with different parameters. I can't have two versions of the same method with the same parameters, that's not allowed, but as long as the parameters are different, I can have two different constructors just like I can have two different any other methods. That's called constructor overloading, just like method overloading. It's the exact same thing, it's just they happen to be constructors. Okay, so we'll deal with growling and eating later, but we now have a new data type called dog. So let's go ahead and actually make some dogs. So over in our main file, which is over here, we mentioned that we could make a dog, just like we can make any other animal or any other variable. And so I had done int x to make an x variable, and now I'm going to do a dog y. It's a little bit more to it than that. We're going to always want to say new anytime that we make a new dog. And so the way that this is going to actually work is we're going to make two variables. We're going to call them J1 and J2. You'd think they'd be dog1 and dog2, but we're going to call them J1 and J2 because reasons. So if we look over in memory on the computer, what's happening when I say dog J1 and dog J2 is it creates two variables, and right now they're both pointed to a magical place called null, because there's nothing on either of them. I haven't actually created the dogs yet. I've just declared that there are two variables that are allowed to have dogs on them. And likewise, if I were to look at this x that I created in memory, that x would also technically have started off life as pointed to null, but Java automatically initialized x to 0. And the reason that it does that is because it knows that all numbers should start off as 0, and so it just goes ahead and does it for you. But it doesn't know what a dog starts off as, because that's a complex type that you're defining. So in actuality, the J1 and J2 are still actually pointed to null. Okay, so to put this in the worst possible terms, right now we have two dead dogs. There's no actual dogs there, there's just placeholders for where we can put dogs later. And so that brings us to the magical keyword new, which brings a dog to life, or it brings any object to life. It's what we actually use to create objects. So to fill it out a little bit more, we're going to say J1 equals new dog. So J1 equals new dog, and I have choices as to how I create it. So I'll do J1 equals new dog and J2 equals new dog, but for J2 I'm going to put in some numbers, and then I'm going to put in a name. Our dog, of course, is called Fluffy. So what's happening here is I'm choosing which one of the constructors to call, and I'm doing this while I'm creating the dog. So in this case, it's going to call the default constructor of a dog because I passed no parameters when I created the dog. So I just said J1 equals new dog, and the parentheses are empty. So it knows that that's a call to this constructor, which is called the default constructor. The other dog that I created, J2, In that case, I did actually pass it two parameters. I passed it a float or a double and a string called Fluffy. So in that case, it knows I'm referring to this one, and it's going to go ahead and set up the dog with its weight and its name. So looking over here on our little memory chart with this new statement, so in here the code was J1 equals new dog, 14 and Bob. It notices that this constructor is the matching one because it takes in a float, and you might say, wait a minute, that's not a float, that's an integer. It knows how to convert an integer into a float or a double, because 14 is obviously just 14.0 in floating point, so it will automatically do that conversion. It won't do it the other way because it's lossy the other way, and what that means is 14.0 converted back to 14, you're losing information by chopping off that 0.0. Now, if it literally is 0.0, you're not losing anything, but if it's 14.9, you're losing 0.9 to get it back to an integer. So it won't automatically do it in that direction, but it will do it in the other direction. It'll allow you to go from an int to a float or double, but not a float or double back to an int. All right, the string doesn't have this problem, it's just a string. Strings are strings. So it realizes that this is the constructor that is being called. So right after this line of code is executed, what happens is that J1 creates a new dog. There's actually a new block of memory that is no longer null where dog J1 is going to be held. And then it starts executing the constructor automatically. The moment that you do this new dog, it automatically calls the constructor for the dog, because in order to create the dog, we must construct the dog, and that means we call the constructor. And since it has these two parameters, it knows this is the constructor we're talking about, so it has decided it's going to call this constructor. So it passes 14 into the W, it passes Bob into the name. And so rabbit is set to false, weight is set to 14, and name is set to Bob. And that's because those are the parameters that were passed in to this constructor. So at the end of this statement, what has happened is J1 now actually is a dog, and it has rabbit and weight and name just like all dogs are supposed to have. Okay, so let's do another one. J2 equals new dog, and this time we're going to pass it 7 and Ethel. Ethel is a terrible name for a dog, but we're going with it. Alright, so again, we're calling the same constructor because it has the same parameters, a float and then a string. And again, as soon as this starts happening, J2 is given a new block of memory, the constructor is called, the values are passed down, and all of the details are filled into J2. Now, a very important thing to notice about this chart down here is that J1 is a dog called Bob, and J2 is a dog called Ethel. They are both separate from each other. J1 and J2 are two separate dogs. There are two dogs in this world. We still only have one class dog. We've only declared what a dog is once, but we have two instances of a dog that have now been created, Bob and Ethel. And so these two instances will continue life for the remainder of the program completely independent from each other. And the reason I keep emphasizing that they're independent is they have different names. To be clear, the class dog says that they both have a name attribute, which is a string. That's all it says. But when J1 was created, the name was set equal to Bob. When J2 was created, the name was set equal to Ethel. And you might say, what is this J1 and J2? Well, those are variable names in my code. They can be anything. You can call them whatever you want. I agree J1 and J2 are completely stupid names, but they can be anything, and that's kind of the point here. We certainly could have called them Bob and Ethel, and that way the dog Bob would actually be called Bob in the code, and that probably would have made more sense, but in this case we decided to call them J1 and J2, some generic name for dogs. Alright, so now we need to make the dogs be able to do stuff, so we're going to add two more methods to our dogs. We're going to add an eat method, and we're going to add a growl method. So I'm going to do the same thing over here in my code. So we have public void, because eating doesn't return anything. And so we have public void eat, and what it takes in is a double, which is the amount of food. How much food are we feeding them? Alright, so the way that our eat method works is their weight immediately increases by the amount of food that they ate, and then it prints out their name and their weight. Now, we can debate how eating actually works. Certainly for me, if I eat anything, I immediately gain that much weight. But eventually it kind of works itself out, if you know what I mean. All right, so weight plus equals amount of food. And the other thing was it printed out what did it print out? It printed out their name and then weighs and then their weight and then the word pounds or LBS. All right, and then we have a semicolon at the end. Okay, so we have an eat method, and then we're also going to go ahead and put in the growl method. The growl method returns a void also, and all it does is it just prints out name says grrr. I feel like the person who wrote these slides has never had a dog. Dogs don't say grr, they say woof. For more informative things, tune in later. All right, so that's our growl method. So let's move on and let's see how we use all of these. So the next thing we have to talk about is the dot operator. The dot operator is used on an instance or on an object to either access attributes in the object or to call methods in the object. So this is how we are going to use our dogs. So over in main, we've created dog 1 and dog 2. And I'm just going to make it consistent with the example that's in here just to be less confusing. So the first dog was 14 and its name was Bob. And the second dog was 7 pounds, I guess, and their name was Ethel. Okay, so E-L, not A-L, not Ethel. All right, Ethel. English is such a weird language. Okay, so now that we have added these attributes or these methods in here, I'm going to ask J1 to growl. Now, you can see straight away that when I typed J1 dot, it gave me a list of methods that I can do on J1. And the things I can see are there were attributes, rabbit, name, and weight, and then there were methods, eat and growl. There were some other methods down here as well, but this is all that I have declared. The other ones automatically come in and I'll explain why they're here. But eat and growl are the two that I've added. Eat requires an amount of food, growl doesn't require anything. So growl is a method. Anytime you're calling a method, you have to have the parentheses at the end. And so if I run this code, it's going to create a J1 dog and a J2 dog, and then it's going to make the first one growl. And it says, Bob says grr, like all good dogs. Grr. Okay, so we could also have J2 eat. So J2.eat, and we have to tell it how much it's eating. J2 is going to eat 2 pounds of food. All right, so when we run this, J1's going to still growl, Bob says grr, but good old Ethel now weighs 9 pounds. And if you look at Ethel's original creation, she started off life as a 7-pounder, and after eating 2 pounds of food, she's now 9 pounds. Footnote: if you are a 7-pound dog and you eat 2 pounds of food, I think you're going to have bigger problems than your weight going up by 2 pounds, but we're going with it. All right, so you can call either method on either one, and we can call them over and over again. So there's no reason why we couldn't do this in a loop. So for int I equals 0, I less than, let's say, 100 times I plus plus, and we're going to have good old Ethel eat a pound of food. Ethel's about to be a big girl. All right, so what's going to happen here is Bob says grr, just like he always does, but then Ethel eats a pound, and now she's gone from 7 to 8, then she's gone from 8 to 9, to 10, to 11, to 12, and since I did this 100 times, by the end of it, Ethel weighs 107 pounds. There are many problems with this, but we're just going to move on, okay? All right, so the important part of this slide is that the dot operator, that period that we're typing in here between the name of the object, which was J2, that's the variable name of the object, the dot allows us to then specify a method that we want to call on the object. And so J1.growl, J2.eat. And of course you can call eat and growl interchangeably on them. You could have Ethel growl every time that she eats. So J2.growl, this means that she's going to eat a pound of food and then she's going to growl. Then she's going to eat a pound of food and then she's going to growl. This actually may be why she's saying grr, because she just ate a pound of food. Okay, so moving on quickly. You can call methods on there. We can also access individual parts of the dog in order to see what's happening. So I'm going to get rid of this loop just so we're not, force feeding our poor dog huge amounts of food. And we're going to run it again, and we're back to something more normal. So Bob says grr, Ethel gains a pound, and then Ethel says grr. But I can actually access all of the attributes in there as well. So I can tell whether Ethel is rabbit. So I'm going to print out and then I'm going to type J2, which is Ethel's variable name, dot rabbit. So just like I was accessing a method, I'm also able to access their attributes. The big difference is when it's a method, it always ends with the parentheses. When it is an attribute, there are no parentheses there. To be clear, that parenthesis that you're seeing is part of the print line, not part of the call to rabbit. And so it says Ethel is rabbit false, because like all good dogs, she was born unrabbit. I'm not sure unrabbit is a word, but we're going with it. Okay, so that's how you access attributes and also how you access methods inside of a class with the fun dot operator. So here we have J1 eat, J1 growl, change the name of J1 to Fluffy. You can set variables just like you can read them. J1 eat, J2 eat. J2 eat -1. Buh. Okay, moving on. Multiple constructors, as we said, are called overloaded constructors, and that's what I did in my example. I had 2 constructors in there. So this is just showing us that that's possible. In this case, they added in the default constructor, which I had already added in, but they decided that if you don't specify the size of the dog weighs 1 pound and their name is unknown. All right, so possible to have more than one constructor. Overloading the constructor involves using the same method or function name, varying the number of parameters and or the types of parameters and or the order of the parameters. All right, so here's an example. Class BMW Z4. It has a model year, it has a license plate, and it has whether the top is up. This has 2 constructors, one that just assumes it's model year 2004, the top is up is false, and the license plate says dealer. The other one takes in a year and allows you to specify which year it is because, well, it turns out every year there'll be a different model year. So multiple constructors are possible. So if we take this example and we create a my car, which is equal to new BMW Z4, and then open close paren, if we look at that particular car, you'll see that its model year will be 2004, its top up and down will be false, and its license plate will say dealer. Whereas your car, new BMW Z4 2007, will be of a 2007 year because it'll call this constructor and actually set the year when it's creating the car. All right? So let's take a look at a problem. Class dog. We have our rabbit, we have our float, and we have our name. And then we have a constructor. And in the constructor, we decide that we're going to allow them to set all 3 of them. So logically, we say dog, which is the name of the constructor, and then in parentheses, we write Boolean rabbit because we want to take in a rabbit, float weight because we want to take in a weight, and string name because we want to take in a name. So far, all is good. But then how do we set the variable? So Boolean rabbit up here is what I'm trying to set, and the thing I'm trying to set it to is rabbit, which leads to the rather confusing line of code, rabbit equals rabbit? But I mean this rabbit here, and I mean this rabbit here. So it makes sense to me, but it doesn't make sense to the compiler, and Java does not like this. If you try to write this code, it's going to puke very badly at you. It's going to eat -1, as it were. So you can't do this. You can't have a variable name in the method, which is the same as the one here. And if you take a look at the code that I wrote, you'll notice that I avoided this problem because in my method, instead of taking in weight and name, I took in W and N. And I said weight is equal to W and name is equal to N. This is the easiest way to get around this problem of having the same name up here as you're using up here. So don't ever do this that's on the slide where you're taking in three parameters and you name them the same as the variables in the class or the attributes in the class. Instead, you're going to abbreviate them or name them something different. It can literally be anything else. So it can be new rabbit, or it can be rabbit1, or it can be R, or it can be RAB, or whatever you want to call it, as long as you don't call it rabbit. That's the easiest way to avoid this. There is another way to avoid it, which is with a keyword called this. This part of the lecture will involve me saying the word this way too often and then grimacing. So if you do decide that you have to have the variable be called the same as the attribute in the class, then the way that you fix it is you say this.x, which refers to the one in the class, is equal to x, which refers to the one that came in as a parameter. It's a bit confusing because the word this actually refers to the class attribute, not to the method x. You would kind of expect it to talk about the method x, but it doesn't. It talks about the one in the class. So to be technically correct, this refers to a variable or an attribute in a class, as opposed to the one in the method. So that's how you do it if you really insist on calling this attribute x, but really the easiest answer is don't call it the same thing as the attribute in the class. And again, don't call it x. I know this is in the example here, but if you just called it something reasonable like weight or, height or fur color or whatever, then you wouldn't really have had x equal to x in the first place. You would have had fur color equals f or fc or something like that, which would read a lot better. So that's the this keyword. All right, so our full example. We have our class dog, we have our boolean, our weight, and our string name. And then we have a constructor that takes in the three of them, and we did use the same name, so we use the this keyword in order to make that possible. All right, so the next topic to mention is constructor chaining. What constructor chaining refers to is if you have more than one constructor, you can actually call another constructor inside of your first constructor, which seems kind of weird, but there's actually a reason to do it. So let's take this example. So we have a default constructor, which is dog, and then we have a constructor that takes in rabbit, weight, and name. So this one is exactly the same as before. This.rabbit equals rabbit, this.weight equals weight, this.name equals name. Nothing has changed here. But our default constructor, the one that took in no parameters, is now, instead of having rabbit equals false, weight equals 4, name equals fluffy, all it's doing is it's calling the other constructor that already takes in those parameters. And that's also done with the keyword this. So this has two different meanings. If it's used as a method call, and we know it's a method because of the parentheses, then it refers to a call to another constructor. It's only used in constructors this way. This is only used in constructors this way. And in this case, it's going to call the constructor that takes in a boolean, followed by a integer or a float, followed by a string, which happens to be this constructor. So if you make a dog and you pass nothing as parameters, what's going to happen is it's going to make a call to this constructor because you'll pass nothing in the parameters, and then this constructor will immediately call this constructor with the three parameters passed in being false, 4, and fluffy. So it's just a way of allowing you to not have to write rabbit equals false, weight equals 4, name equals fluffy inside the default constructor. You simply use a different constructor that already takes those things in. And again, you might be thinking to yourself, I don't know why you would really do this. If you've just got three parameters, it doesn't matter. And you're right, but imagine if you had 100. Or imagine if you had 100 and then you needed to add 4 new ones. If you have to do it in every single version of the constructor, that's going to be really tedious, whereas this way you don't have to do it in each one. You just have all the other ones call the one that takes all of the parameters that you care about. Default constructors. So let's talk about this. In Java, whether you write a default constructor or not, it's going to add one for you. It's going to add it invisibly, which is a little bit weird. So what am I talking about here? So if we go back over to my code, where we have this public dog constructor, this is what's called a default constructor because I'm not taking in any parameters. This, by comparison, will be called an overloaded constructor because it's an overload of the default. The default constructor, as I say, doesn't take in any parameters, and it sets up some attributes to default values. So you could imagine that Java can predict what you're going to do with the default constructor most of the time. And so that's exactly what happens. If I go into my code and I erase both of these constructors so that I have a class dog which takes in or which has 3 attributes and it has 2 behaviors or 2 methods, the only reason that it's saying there's a problem is because over in main I have filled in 2 values and there's no corresponding constructor that takes 2 values. But if I take those values out, you'll notice that all of a sudden the code is now happy. The 2 problems are now gone. So you might say, but there's no constructor. How can it construct a dog if it doesn't have a constructor? And the answer is, it makes a prediction as to what it is that it thinks you're going to do. It makes a default constructor that just sets everything to their default values. And the default value for a number is 0. The default value for a string is null. It's not an empty string, it's actually null. And the default value for booleans is false. So it just sets that up automatically. So what I'm telling you is, this code compiles and runs. I can absolutely 100% switch over to main, and I can run the main method, and everything will run. And my dog's name is blank, so where it's supposed to growl, it's printing out the name, says grr, because that's what our growl does. The name is blank because, well, it never got set. And you might say, well, it did get set. You set it to blank right there. Okay, just to prove a point, I'm not going to set any of the attributes. I'm going to run the code again. I have to go back to main to run the code because you got to run the driver class, not the subclass. It says null says grr, null weighs 1 pound, null says grr, Ethel is rabbit, false. So the reason that Ethel is rabbit is printed is because that's in the print statement. It's right there. But it's just printing out the value of it. So you can see that Ethel's rabbit status is false because that's automatically set by Java. Booleans are automatically set to false. The weight is 0. After they ate, it becomes 1, and that's what happened here. I had them eat 1 pound, and then it printed out that they were 1 pound. But they were initially set to 0, and the name is set to null. So to be clear, what Java automatically did was this. That's the default constructor, and it's automatically written for you without doing anything if you don't put a constructor in. So, you have a choice. You can build a constructor that sets things up how you want them to be, or you can allow Java to set them to the defaults. As I say, that's exactly what it would have looked like had you not written one. That's what it would have written for you. So you might wonder, well then, do I need to write constructors? Do I not need to write constructors? This is all very confusing. And the answer is, most of the time you probably need to write a constructor. Most of the time you're not just dealing with weight equal to 0. So if you take something like age, does it start at 0? Probably not. Honestly, weight doesn't start at 0 either. Nobody's born 0 pounds. You might be born less than 1 pound, but you're not born at actually 0.0 pounds. That's not how this works. So the defaults might not make sense, and usually they won't, and in that case you need to have your own default constructor that sets them to what makes sense for this. We're talking about the class dog, but we could be talking about the class student, in which case your KSU ID needs to be set to some 9-digit number, not 0. And likewise your name probably needs to be set to something that's not null. So usually you're going to write your own, but if you don't, Java will insert one for you that does the bare minimum. It's important that you realize that the bare minimum is very often not what you want. So usually you're going to write your own. Okay, moving on to the next topic. We're going to talk about this magical public word that I've been dancing around for the last 4 PowerPoint presentations. So every time I mentioned that you need to create a method, I said public and then the word, whatever the name of the method was, and so on and so forth. And I told you I'd come back to it. So here we are. Let's come back to it. If you have a attribute inside of a class, you actually get to specify whether or not it's public or not. So let's take string name. By default, Java put in public on front of this. So this code will work exactly the same as it did before. As a matter of fact, Java automatically put public on front of all of these words for me. Every method starts off public, all of the attributes start off public. This is what Java does to make your life easier. It puts everything to public. But that's actually not what you're going to want to do. Public means that anyone can change it. So let's give our dog an age. Public int age. And in our little default constructor, we'll set age to 0, and we could have a method that increments their age by a year and all kinds of stuff like that. So let's go over into main, and let me do something here. I'm going to get rid of these growls and eats. I'm just going to comment all of that out for a moment. Okay, I'm going to say j1.age is equal to 14. And then I'm going to run my code. And what's going to happen is, it's just going to print out Ethel is rabbit false, but it set the age of J1, which is my first dog, to 14. So the dog was created with an age of 0, and magically in one line of code, I made the dog 14. You know, this is how it works in the real world. When you're walking down the street, you can look at any dog, point at them and go, "You're now 14." And poof, they're 14. Okay, that's not actually how it works in the real world. And it would be horrifying if that was how it worked in the real world. The things like age shouldn't be changeable. I shouldn't be able to walk up to a dog and change their age. I also shouldn't be able to change their name. The dog gets to pick its name, and then, well, okay, the dog doesn't pick its name. Maybe dogs should pick their names. But anyway, humans pick the names, and then the dog has that name for life generally. But it's not something that a random person can walk up in the street and change. And so that's why we have the ability to set things as public or private. I'm going to change age from public to private in the definition of the class. And immediately Java says, well, there's a related problem. You tried to change the age out here, and it says age has private access in dog. This means I'm not allowed to do this. If I try to run this code, it gives me that same compile error and tells me I'm not allowed to do that. Age has private access in dog. It's no longer allowed for me to change the age of the dog out here in main. So you might say, well then, how does the dog age ever change? If it's private, no one can change it. Well, what private means is the dog has the ability to change it, but no one else does. So I'm going to add to the dog a method, public void get year older, which is simply going to say age plus plus. And then for giggles, I'm going to add a print statement, get to know dog. All right, and what I'm going to print out is I'm name and I'm age years old. Okay, so the dog is printing out their name and how many years old they are. It's called get to know dog. So over in main, I'm going to j1.getToKnowDog. I'm going to get rid of this Ethel thing. And I'm going to do the same thing for j2. So it's just going to print out the two dogs and their current ages. Now, when we run this, we're going to see that j1, because I never set anything about j1, their name is null and they're 0 years old, because that's the default constructor's work over here. It set age to 0 and weight to 0. So, and their name to null. All right, I'm going to change their names just so that, or give them the ability to set a name. So I'm going to make another constructor, which we're going to take in a name. Oops. All right, so in my second constructor here, I'm going to take in a string n, and I'm going to set the name equal to n instead of setting it equal to null. All right, I'm going to go back over into main, and in main, I'm going to pass myself names for the dogs. So we've got Fluffy, and we've got Growler. Okay, so Fluffy and Growler, because he growls a lot, I don't know. They're both 0 years old. So now I'm going to tell Fluffy to get a year older. I'm going to say j1.getYear, j1.getYear older. And now I'm going to get to know my two dogs, and you're going to see that Fluffy is now 1 year old. And so, for example, if I did a loop, int I equals 0, I less than 15, I plus plus, and inside of my loop, I have each of the dogs get a year older, and then I have them print out everything about themselves, so I get to know both of them. You'll see they're both 0, then they're both 1, then they're both 2, then they're both 3, 4, 5, 6, all the way up to 15. Alright, so this is what you should be doing. All attributes in a class should be set to private. Okay, I'm going to say that again. Although Java defaults them all to public, the way that you should be writing your classes is that all attributes should actually be set as private when you create the dog, or any class for that matter. So our rabbit condition should be private, our weight should be private, and our name should be private. And the reason that they're all private is because no one should be able to just look at me and make me rabbit. No one should look at me and change my name or change my weight. All of those things are things that I, as a dog, should be in control of. This is called encapsulation, and it's one of the most important attributes of object-oriented programming. The object encapsulates its state, and it doesn't allow people to mess with it except through particular methods that it exposes. And so you might say, well, I am allowing them to change my age. I have this getYearOlder that does age plus plus. But notice that immediately based on this, can you make my age -10? No. The only thing you can do is you can create a dog which starts off at age 0, and you can call getYearOlder, which increments it by 1. It goes up by 1. So that means it's impossible to have a dog that's -2 years old, or -3 years old. And you might say, well, that's stupid. Why would you want the dog to be -3? Well, if it's public, anyone can make it -3. Think about it this way. Imagine that there's one person in a game who has to render a health bar at the top of the screen. And that health bar is, it starts off at 100%, and then every time you get attacked, the health bar shrinks back down again. Well, what if the health bar is -7? How's it supposed to draw that picture? Because it's supposed to be a bar from 0 to 100, so what does it draw for -7? Chances are if you make the health -7, the game's going to crash. So you would want to make sure that each character's health can never be anything greater than 100 or less than 0, presuming that's what you're trying to do with the game. It makes it so that it's very intentional as to how you're setting all of the attributes inside of your classes. So again, I'm going to repeat this, all attributes inside of your classes should probably be private. There is occasional moments when they should be public, but 99 times out of 100, they should all be private. Now, let's talk about behaviors or methods. The methods in your class, like eat and growl and getYearOlder and getToKnowDog, they all have to be public, otherwise you can't use them. If I change getToKnowDog to private, and I go back out to my main method, you'll notice that it no longer works. I can no longer call getToKnowDog because that's not permitted, because getToKnowDog has private access in dog. So generally, methods should be public, because why did you write the method if you don't want somebody to be able to call it? The whole reason for having methods in the first place is so that people can get to know your dog, so that it's public, it's something that can be done. Alright, so the specific definition of public and private is that private can only be accessed inside of the class, or inside of the object specifically. Public items can be accessed anywhere, outside of the class or outside of the object in other objects. So my main method is inside of a main class, and my dog is in a different class. Therefore, anything that's private to dog cannot be accessed in main. And likewise, anything that was private in main can't be accessed in dog. And likewise for any other things. Public things, on the other hand, can be accessed in either one. So, generally, attributes are private, and generally, methods are public. Alright, so there's the roles there. Private variables, public methods. All right, so let's give another example. We have a class BMW Z4, and it has a couple of attributes which are model year, license plate, and top up. So, which things would we want to be private and which things would we want to be public? Well, the model year is not something I should be able to change or see. The license plate is probably something you would want people to see. So there's two ways to do that. The better way would be to make the license plate private and then have a method called getLicensePlate, which simply returns back the license plate number. That's called a getter, and it's a common way of dealing with the idea that you want to make something read-only. You just provide a public getter, which allows somebody to see the information, but no public setter, which is what allows somebody to change the information. Because a license plate is not something they should be able to change, but certainly people might need to be able to see your license plate. So you could either make it public, which is the sloppy way of doing it, and that does allow anyone to change it as well as see it. There's no keyword for read and write. It is just either public, which means they can read and write, or private, which means they can't read or write. So those are your choices there. And so here we have our visibility example again. If we have it set the way that it is here, where this is private model year, public license plate, and private top up, then when we've made our new car, so my car equals new BMW Z4, I'm allowed to say car.license plate equals whatever it is. That's allowed because it's public, but car.model year is not allowed because it's private. Car.drive is allowed because it's public. Car.openTop is allowed because it's public, but car.pollute when no one's looking is not allowed because it's private. In this example, emissions pollute when no one's looking. It returns emissions. Clever. All right, so how do we change private variables? Well, as I mentioned, you're going to use getters and setters. So back over in my code here, I have an age variable, and I've now marked that age variable as private because no one should be looking at it. But if somebody wants to know how old I am, I might want to be able to answer that. And so I'm going to create a getter. Generally, what you're doing with a getter is that you're allowing someone to access each of the attributes. So in this case, age is an int. So this method is going to return an int, and I'm going to call it getAge. You'll actually notice that IntelliJ automatically prompted me for getAge because it knows that I probably need a getter here. And all it's going to do is return the age. That's literally all it's going to do. So now I have an age that is accessible. People can look at it, they just can't change it. So at any moment I can say j1.getAge, and that's going to tell me current age. Remember, it returns a value, so you'd want to capture it. And then I can do whatever I want with that. J1's age is current age. There needs to be a plus sign there, and there needs to be a semicolon at the end. Okay, so that calls getAge, which is perfectly legal, and it prints out their current age, which is changing because we're in a loop and it's moving every time. So that's called a getter. A setter, on the other hand, is something that allows you to change something. So if we wanted to allow people to set age, then we would have a public void setAge, which takes in a new age, and then we'd probably check to make sure that the age makes some sense. So you might say, well, if you're giving them a getter and a setter, then why didn't you just make it public? Well, the answer is exactly this. With a setter, I can write code that validates that they're not giving me crazy numbers. The health shouldn't be below 0, it shouldn't be above 100 maybe, depending on the game. So I can have an if statement that says if the new health is below 0 or the new health is above 100, tell them no, I'm not setting it to that. Or set it to, if it's below 0, then just set it to 0. Which means it's still a valid number and it'll still render correctly, because it turns out if you're negative 5 health, then you're still, really 0 health, right? And likewise, if you're above a certain health, maybe it's really you're just at 100% health. Likewise, for our age here, probably want to check that the age they're giving you is reasonable. I would say in addition to checking that it's less than 110, maybe you also want to check that it's greater than 0, and you probably also want to check that it's actually a number. Those are all valid things to do. So your setter would have limits in what it will allow. It's basically giving you protection to stop the encapsulated data from being corrupted with some random meaningless number. Okay, So here we have our class BMW Z4 again. It's got its private model year, its private license plate, and its top up. And then we have all the things that we need for those attributes, which is a setter and getter for model year, a setter and getter for license plate, and a setter and getter for top up. To be clear, each of these has its method body on the same line. Again, that is possible. You would never really write it this way. This is just to save space on the slide so that you can see what it looks like. But the getters basically just get a value and return it, whereas the setters allow you to change a value because they take a parameter in. All right. So our next topic is something else that you're going to want to do with objects sometimes you want to be able to treat an object as if it is printable. So in our example here, we have two dogs. And you might wonder, what happens? I'm going to get rid of this code that, is changing the age and all of that fun stuff. What would happen if I just printed out my dog? System.out.println J1. I certainly could have done this with x. X is a variable that's an int, and if I had printed it out, I would have just gotten, whatever the value of the variable is. So if I print out a dog, it'll say Fluffy, right? No, that's not quite Fluffy. And in case you're wondering, does that say Fluffy in some clever way? No, it doesn't. Just for giggles, I'll print out J2 underneath it. And you'll see that it's just some long... It says dog at, and then it's a long string with numbers and letters, where the letters only seem to go up to F. Okay, so what's actually happening here? Well, the dog J1... If we were to go back a million slides, there was that slide where we had all of the locations of the dogs. Remember in memory? This slide. And remember I said that initially J1 and J2 both pointed to null. And then when you created J1 and J2 and you executed their constructors, they suddenly got new blocks of memory that held it. Well, that's exactly what Java is printing out. The address in memory where J1 is located, which is very useful information. It's not useful information. You will never want this, and it's kind of crazy that this is what it does, but the default behavior is if you print a complex data type like a dog, it will print out the name of the class followed by an @ sign followed by the memory address where that object is actually located. That memory address is useless to you. You will never need it. So, if I don't want Java to do this, what can I do? Well, there's a magical method that you can change which allows you to get something different than the memory address. And so the way you do this is a little bit weird. I'm going to type the word override with an @ sign on front of it, and then I'm going to say public string toString with parentheses. And I'm going to return hi, I'm plus name. Okay, I'm now going to run my code again. Bear in mind this is the only thing I've changed in the code. In the main method, I'm still printing out J1 and J2. So in the past, I was getting this weird memory address, and now instead I get hi, I'm Fluffy, hi, I'm Growler. Why? Because this method is what got executed when I printed out J1 and J2. ToString is a magical method that is always in your class. Now you might say, what do you mean it's always in my class? It wasn't there until you just wrote it. You're right, it wasn't there until I just wrote it. But it's always magically there somehow in the background, and I'll explain why in a future slideshow. Probably the next one. Or maybe in 2. Either way, ToString gives you a string representation of a complex data type. So since our dog is a complex data type, it's giving me a string representation. The default is the string representation is the memory address with the word dog on front of it because the class name is dog. But if you change what that representation is using this override of toString, then it'll do whatever you tell it to do inside of here. So let's talk through this. This is just a method. It's a method that's called toString that returns a string, and it's a public method. It takes in no parameters, and indeed it returns a string. The string says, hi, I'm name. I'm able to access name even though it's private Because it's within my class. I'm writing this inside of the dog class. This is a method in the dog class. So the dog has access to the dog's name because the dog's name is private in the dog class. Anybody inside the class has access to it. So that's why I'm able to see this. But what toString does is it returns a string representation. When you print something, it has to be converted to a string. And so since I asked it to print J1, which is a dog, what Java did was it asked J1 to be converted to a string by calling the method toString. So it actually effectively did this, which you can actually type out, and that's perfectly acceptable, but it did it automatically. And it always does this automatically when you have anything in here that is not a string. It has to be converted to a string in order to print it out, because that's what our print statement does. This is kind of cool. In Python, if you remember, if you tried to print out an integer inside of a string, like you had a string like the value is, and then you tried to do plus and then an integer, it didn't work. It said you can't do that. Java does it because it asks the integer to convert itself to a string by calling toString on the integer. And there's a magical toString on everything that'll do it. The ones for complex types that you've written, they do something crazy like printing out the address, but the one for integer, it knows how to convert an integer to a string, so it returns a string representation of the integer's value, which is why you're able to do plus and an integer inside of Java. It implicitly calls toString for you. So, to review, anytime you treat an object as a string, Java will automatically call toString on the object, which will convert it to a string. At that point, you can use it as if it's a string, so it can be printed or whatever else. If you don't specify what toString does, then it'll automatically give you some crazy memory address because that's the default in Java. But if you do specify it by creating an override of the method toString inside of your class, then it will do whatever you tell it to do. So that's what overrides of toString looks like. It's always going to have this @override and then public string toString, that should be a capital S right there, I'll fix that, and then it'll return name plus whatever you want to return. Whatever you return is what the string is going to print itself out as. Okay, so that is our toString override. Let's talk just a little bit about the toString override as I correct that typo on the previous slide. So why is this magical thing @override written on top of it? And does it work if I don't put that @override in there? And the answer is yes, it does work, and it's something we probably need to talk about. So over in our dog class, I'm going to take away this @override, just deleted it. It's supposed to be there. The correct thing is for you to always put it there, but I'm just going to remove it and I'm going to run the code again. And what you're going to see is that the code still works exactly the same. It says, hi, I'm Fluffy, hi, I'm Growler, just like before. Everything is hunky-dory. So if it's not necessary, why did I put it there? Well, this is called a compiler directive. It's basically a comment, but it's a comment that the compiler can read. It starts off with this because I'm talking to the compiler, and I'm saying this is an override. What I'm telling the compiler is, I'm hereby intending to override a method. We're going to talk about the details of this later on, but for now, what you need to get is, you should always put that @override on top of your toString override, even though it works without it. I'll give you more detail on that in a future presentation, but for now, get in the habit of always putting @override on top of your public string toString. All right? So, in summary, Python and Java both have features. Both of them feature classes and objects in the same way. There are slight syntax differences. In Python, fields declared in the body of the class belong to that class, whereas in Java, fields declared inside the body of the class belong to individual objects. So that means that if there's a name attribute, when I'm created, I'm made Enda. When you're created, you're Ethan. No, seriously, you're now Ethan. I've told you because it's public and you made that mistake, so you're now Ethan forevermore. And if you happen to start as Ethan, then good luck. All right, so attributes inside of a class belong to each individual object. My name is my own, and no one else should be able to change it. Your name is your own, and no one should be able to change that. That is really not true in Python. And it's a bit goofy that it's not true in Python. So that's one change. Again, Java is strongly typed and it's very protective of its data, which is why you can build these bigger, more complicated things with it. All right. These fields are shared amongst all objects of the class until an assignment is done, whereas here only static fields belong to the class itself. Something we're going to talk about in the next presentation, static. Okay, constructors are called underscore underscore init when you're in Python. The constructor has to be called the same name as the class name in Java. The keyword to specify the object itself is self, whereas in Java it's this. Remember the this keyword from half an hour ago? All objects can have fields added or removed after the program starts. All objects are set in stone once the program starts in Java. Again, because Python is interpreted, as the code is running, you can suddenly add an attribute to a class. You can't do that in Java. You have to declare the class up front before it's ever used, and then once it's instantiated, once the program's running, you cannot change what attributes are there. You can't add an attribute or remove an attribute. Okay, we have one last topic to discuss in this presentation, and this one is going to make your head hurt a little bit. So I know we've covered a lot of material, and I know that you probably had a lot of new learning that went on in there. This one is going to be very important, so I want you to pay attention here. If you need to take a break, go ahead and take a break. In the last PowerPoint presentation, we discussed how passing a primitive type into a method worked. And so if I go back to the previous presentation, so if I open up my IntelliJ IDEA projects, here it is, 2.1. Okay, so if I open up my 2.1, this was the presentation from the last time. One of the things that we did was we had this. We had int x is equal to 10, and then we made a call to do stuff, and we passed it, well, it was 11 by the time it got there because of this plus plus. And remember what I told you is that the value of x is copied up to the value of x here. They're two separate x's, but the value 10 is copied up here. If you didn't watch that presentation, you're going to want to go back and re-watch it, especially after we go through this. But even if you did watch it, you're probably going to want to re-watch it, because what I'm about to tell you is going to make it very confusing. If you are passing a primitive type to a method, and again, the primitive types are shorts, bytes, ints, longs, floats, doubles, chars, and booleans. If you're passing a primitive type to a method, it passes a value to the method. Here's the new data. If you're passing an object to a method, it still passes a value to the object, or to the method, sorry. It still passes a value to the method, but the value it passes is the address in memory of the object. Okay, so what do I mean by that? So let's go back to our other presentation 2.2 here, and we're going to use our dog. So we're back to where we were before. We have our dog. It has all these methods and all this stuff. And over in our main method, we created two dogs. So what I'm going to do is I'm going to create a new method inside of my main class. So I'm going to do public static void autofeed. All right, and I'm going to take into this method a dog, which I'm going to call the dog. Okay, to the dog, I'm going to feed the dog a pound of food. And I did this down here, so I'm just going to grab this line of code. So for I equals 1 to 15, let's do 1 to 100. And what I'm going to do is I'm going to take the dog and I'm going to make it eat 1 pound of food. Okay, so let's talk about what's happening here. And I'm going to simplify some of this other stuff, so I'm going to get rid of all these two strings and all this other stuff. I'm going to simply say auto feed J1, missed an O, not a 0, an O. Okay, so I made two variables, J1 and J2. For the sake of this, I can ignore J2. J1 I created as a dog Fluffy that called its constructor, and then I call this local method here in my main class called autofeed, and I passed it Fluffy. I'm passing a dog into a method, just like I was passing integers into a method before. Everything seems reasonable. So, based on what I told you before, if I were able to get the weight of Fluffy, which I think I have a method in dog that gets me the weight, do I? Let's add a method, a getter. So public float get weight, which returns weight. Okay, that's not happy because it's a double, not a float. So let me get rid of that, double. Okay, so I've just added a getter to Fluffy and to all dogs that allows me to get their weight. So I'm going to ask for the weight of the dog before and after this. So double current weight equals j1.getWeight. And then I'm going to do current weight again afterwards, and I'm going to print it out each time. C-U-R-E-N-T. I missed 2 letters. How did I manage that? Okay. System.out.println before, and I'm going to print out current weight, and then after, and I'm going to print out current weight. All right, so to be clear, the only thing that's happening between these two is I ask what the dog's weight is, which is very rude. You should never ask a dog what its weight is. And then you print out the current weight of the dog. Then I'm going to send the dog to the auto feeder, and then I'm going to again ask the dog what its weight is. It's unhappy because I'm redeclaring current weight, so I'm just getting rid of that double, so I'm not doing that. And then I'm printing out the weight. So let's talk about what we think is going to happen here. So when the dog is created, I never specified a weight, so the default constructor on the dog is going to set the weight equal to 0. So when good old Fluffy is made, Fluffy weighs 0. So I would expect that before I send Fluffy to the auto feeder, Fluffy's going to weigh 0. And that's going to be true. Then I'm sending Fluffy off to the auto feeder. And the auto feeder is going to 100 times shove food into the dog's mouth. Alright, so as the dog is being force-fed food, let's presume that the dog is voluntarily eating a pound of food. It's much better than force-feeding. Alright, so as the pound of food is being added each time, 100 times, the dog is getting bigger each time, because the way that eat works is it just adds on to the weight. But from what you know, in the past, in the last slide presentation, when I had an x and I passed it up to a method, nothing changed in the main method because the x in the method and the x in the main method are 2 separate x's. Remember that diagram with the 2 different x's in it? So you would kind of think the same thing is happening here. So again, over on my little diagram here, we had that activation stack, and we had our main method, and we had an x that was equal to 11, and then we called our method, which was doStuff, I think, and it had its own x, which was set equal to 11, and then we added 10 to it, so it became 21, and then doStuff went away, and x was still 11 down here. So if we printed, initially x was 11, and then if we printed inside of here in the doStuff method, it was then 21, but when we came back to main and we printed again, it was back to 11. Because this x is different than this x. The one in red is in main, the one in yellow is in doStuff. So it would seem to make sense that if I were drawing this exact same picture for our dogs, then it would seem like what I would have, and I don't want to draw in yellow, what I would have is I'd still have my little activation stack. Down in main, I would have J1, which is a dog called Fluffy. That's the name attribute, and the weight is 0. And what you would expect to happen is when I call my method autofeed, I'd have the dog, which is the name of the attribute here, would be a copy of good old Fluffy, and I'd have a 0, and then as I feed it, that 0 would become 1, and then 2, and then 3, and then 4, and intuitively, anything that happened up here in auto feed would have no effect on the dog down here in main. That's what would have happened if we were dealing with a primitive type. But we're not dealing with a primitive type. We're dealing with a complex type, in this case, a dog. So we are passing a copy of the reference to the dog, but it's the same dog. Okay, so what I mean is, despite what I just described here, being that the original dog down in J1 was not affected, that is actually not what's going to happen. When we create the dog up in our method called autofeed, what actually happens is, instead of a copy of the dog getting put up here, we actually get a reference or a little arrow that points to the original dog down in J1. And so anything that is done to the dog in autofeed is also done to J1 down in main. So when I change the weight from 0 to 1 to 2 to 3, it's being affected in both places. And I'm going to prove that point by running this code. So again, I make J1, I get J1's weight, which will be 0, I'm printing out before and a 0, then I'm passing J1 to the auto feeder, which is going to feed them 100 times, and when I print back out their weight again, it's no longer going to be 0, it's going to be 101, or 100 specifically. The dog was changed by the auto feeder method. This is very different than what happened when they were primitive types. When they're primitive types, nothing you do in the method has any effect on the attributes in main. But when they are objects, everything you do in the method also affects the original object down in main. So the difference here is the fact that this attribute is a non-primitive type. It's a complex type. The moment that it's a complex type, all of a sudden, anything you do up here also affects the dog down here. So J1 and the dog, as in the diagram, are actually the same object. Now, you might say, oh God, why? Why did they do this? Why would you not make it so that if you're doing it one way for a primitive type, you do it the same way for a complex type? The answer is, a primitive type takes a very small amount of memory. An int takes 32 bits of memory. And a long just takes 64 bits of memory. It's really not very much. A dog, on the other hand, we don't know how big it's going to be. If the dog has a name, the string's going to hold all the separate characters. It's also going to have an age and a weight and all these other attributes. And if we're being honest, it should have a pile of attributes, right? So like its temperament, its fur color, whether it has fur, right? Some dogs don't because they're, whether they shed, whether they're hypoallergenic, whether they're friendly demeanor, whether they're more of a sporting kind of dog versus a lap dog, whether they're good at, defending you versus whether they're good at alerting you to somebody being there that they don't like versus they're just there to be pretty. Dogs come in all different shapes and sizes and all different capabilities, so to be able to truly capture a dog, we wouldn't have 3 attributes, we'd probably have 500. And each of them takes up some space in memory. So if we did it the same way that we do for a primitive type, every time we call a method, we'd have to double the amount of memory that we're using in order to pass the dog. That's what we did for the primitive type, we doubled the amount of memory. When we passed the x up to the method, we actually made a copy of the value in a whole new variable that's in memory. But it was 32 bits, so who cares? Nobody cares, and so we do it. For primitive types, we just copy it. But for complex types, we don't. And you might still be saying, well, this is so stupid, it's so little memory, who cares? How about this? What attributes would a student at KSU have? Well, you have a name, and you've got a KSU ID, and you've got, probably a list of classes that you've taken, and grades in all those classes, and the professor, and the dates and times of each of those classes, and whether you passed it or not. All of this is relevant information that has to be stored about you, plus all the classes you're currently taking, plus all the classes that you'll need to take to get your degree. By the way, we need to store your degree name. We need to store whether you're an online student or an in-person. We need to store your home address, your phone number. We have to keep track of whether your parents have access to your records. We have to know whether you're above the age of 18 because that affects some legal things. We have to know all of this data. We have to know about one student. There's 48,000 of you when I'm writing this video. When I'm recording this video, there was 48,000 enrolled at KSU. That number is almost certainly bigger now. And so all of a sudden, if I were storing the entire student body, that could be gigs of memory. And you say, okay, but gigs, what's a gig? Who cares? My laptop has 16 gigs of RAM because I'm fancy and I bought a nice laptop. Great. But I could actually imagine a circumstance where just storing the student body at KSU occupies all the memory on your laptop. And then all of a sudden your laptop is going to slow down and grind to a halt. Because it turns out once you run out of memory, your laptop has to do this crazy thing called paging, which is all outside of the scope of this, but one way or the other, it's going to suddenly slow down and everything is going to be moving like a crawl. Have you ever had it on your laptop where when you move the mouse, it's doing this? It's not moving smoothly? That's probably because your laptop is paging memory, because it has run out of memory. It's one of the fastest ways to make your laptop go faster is to add more memory to it, which you can do. There's stuff you can, most of the time you can put in another chip, and all that's beyond the scope of this class. But the amount of memory that you have is very important. And also, when you write code, you don't know how much memory the person who runs it is going to have. You may have the baller laptop that has 32 gigs of RAM. The person running it may be running on a laptop with 4 gigs of RAM. And all of a sudden, your decisions as to how you stored things in your Java code may make a difference as to whether it runs on their machine or not. And if you say, well, that's silly, bear in mind that most applications running on Android phones, which by the way account for the vast majority of phones on Earth, are run in Java. So every application that's running on your phone, every variable and everything that it's keeping track of, all has to be stored in memory on your phone. And your phone probably has 4 gigs or 8 gigs of RAM. If you're the really fancy one, you might have 12 gigs of RAM. So it's not that much memory all of a sudden. And by the way, that memory is used for everything, not just the current app that you're running, but all of the apps that you currently have open. So if you've got your messaging apps and you've got 4 of them and you've got Instagram and you've got Snapchat and 12 other things, all of which have photographs, all of that's in memory. So the memory is really important. And that's a really long way of saying this is why Java doesn't make a copy every time you call a method when you're passing it a non-primitive type or a complex type. Instead of passing it the copy of the object, it passes the address of the object. And that address means that both the method and the original main method are both using the same object. Now, to give you a layman's terms version of this, imagine that I have a sheet of paper. And I take that sheet of paper and I hand it to you. And you write on that sheet of paper. I'm trying to pick up a sheet of paper off camera in case that's not clear. Here's a sheet of paper in case you don't know what they look like. It's blank. I take this sheet of paper and I hand it to you. You pick up a pen and you scribble all over the sheet of paper. That's what a scribbled on sheet of paper looks like. You hand that sheet of paper back to me. Note that it has the scribbles on it. It doesn't magically revert back to being a blank sheet of paper like it was when I gave it to you. It has your scribbles on it. The layman's version of this is there is only one instance of the object. The object in this case is a piece of paper, but there's only one of them. And when I call a method, which is me giving it to somebody else, whatever they do to it has an effect on this piece of paper. And so the layman's version of this is when you pass an object, the other person's changes to the object are still visible by you when you get the object back. When you pass a primitive type, that's not true because they get a copy of it. So if I'm passing the number 7 to somebody and they change it, it's not like the number 7 has changed in the entire world. They got their own copy of the number 7 and they did with it as they pleased. That's what's happening with primitive types. With complex types, you're passing the actual object. So, the summary of this is, If you are passing a primitive type, what I told you in the last video is true. A copy of the data is sent to the method, and if the method changes anything, it doesn't affect the original data in main. But the new data is if you pass a non-primitive type or a complex type, an object, to a method, what is changed in the method is changed everywhere. There's only one copy of the object. So let's do an example over here with another dog. So we have our class dog, which just has a weight. And for the sake of this, we're making weight public so that we don't have to do getters and setters. We're just making it simple. This is not good encapsulation. It's purely for this example. So the class dog just has a weight. And then we have our main method where we create a dog, my dog equals new dog. That's how you instantiate a new dog. Then we say my dog.weight equals 10. And since it's public, it's going to allow me to change that. We print out the weight, and we know what we're going to get is we're going to get 10. 10 gets printed on the screen. Now we're going to make a call to B, which is this method up here, and we're going to send it my dog. And since it is a complex type, what I'm going to send it is the address in memory of the dog, i.e. we're both going to have the same dog. So what that looks like is my dog, which is what I call it down in main, is linked to this spot, and X, which is what I'm calling it up in the method, is also linked to this spot. So if I say my dog.weight, it's the same thing as x.weight for the purposes of this. So when I say x.weight plus equals 9, watch what happens. All of a sudden weight goes to 19 in both places because it's all the one thing. So when I print out 19 and I come back down here, I'm still going to print out 19. So anytime you pass primitive type, those are the primitive types to a method, a copy of the value is made. Anytime you pass an object, the reference to the object is passed. This is a very common source of confusion. All right, so the last topic to mention in here, which is related to this, is, well, then what happens if you actually do want to change something on a primitive type? So what happens if you want to be able to send a number to a method and you want it to change, but it's primitive? Well, then that's when you can do this. So here's a method called int changex. It takes in an x and it returns an int. So all it does is it takes in an x, it increments it, and it returns their new value. Down in main, if I get rid of this little banner, all I have to do is say int a equals changex a. And just to be clear, the way this works is the changex a call is going to execute first, and then whatever value it gets back is going to be assigned to a, thus a get updated. Even though a is on both sides of the equal, the thing on the right happens first, the thing on the left happens next. Okay, so that is the discussion of classes and objects. In this section, what you have learned is that we write a class definition which specifies everything that there is about a thing that you're going to make objects of later on. So your class could be for dogs, it could be for KSU students, it could be for people, it could be for burgers, it could be for anything that you want. In that class, you're going to specify what all things of that type are going to know about, what their attributes are, and what their behaviors are. So burgers know how to get cooked. They probably have an attribute of their weight. They probably have an attribute of what they're made out of, what food or what meat they're made out of, or vegetable that they're made out of for that matter. And then on the other side, when you make an object of that, you then get to assign those values. So even though you've defined that a burger patty has a weight and it has a material that's used to make it, we'll call it, you could have one burger patty that is a veggie patty that's made out of beans and whatever you make it out of, and then you could have another one that's made out of pork or beef, and another one that's made out of chicken. You can have multiple different kinds of types. And so each one of those objects has its own separate state, which tells you what it's made of and what its weight is, because they can all be different. But they all share the class, which is the definition. All right, so that completes section 2.2. We're going to do section 2.3 in the next video, and I will see you guys there.